Alright guys, as a reminder, if you don't see a video for a specific day, I try to make sure they're all there. Sometimes I forget. If the video is completely lost, I should post a note on the front page saying so. But if it's not, and you don't see it listed here, you can just click on the all CIT videos, and it does a Google search. And you ought to be able to pick it out pretty quickly from those. What do you use that for? If you miss a day, you're looking at the in-class assignments. I was sloppy. I did not put the due dates on these. So if you miss a day, you look at the Dropbox. If it's an in-class assignment, look at the due date, then go find the video for that day. Just watch the video, follow along. I know it's not the world's most pleasant thing, watching a video and typing text along with it. It's kind of cool if you have two screens. How many people have two screen setups at home? A certain number, but not everybody. That's how you do those. The homework assignment, we actually did the binary hex spreadsheet in class. If you missed it, you can watch the video for it. That video would have been on the 25th. So let's put from Jan 25 video on it. And we'll make a due date on that of tomorrow night. Nah, let's make it Sunday. But almost everybody's already done it. So let's move on to PowerPoint 2, Chapter 2. The parts of a C++ program. We've already been doing all this stuff, so this is going to look real familiar. We know what a comment is. I need to post, and I will do so probably by the end of this week, some specifications for how I want your code to look. But most important, not most important, I do want a comment block up at the top that has your name, has your date, and a description of the program. Then we will just about always have include IOStream if we are writing a standard ANSI C++ style program. If you're writing a Microsoft specific one, you'll do something a little bit different. There are different include files you need to do for that, but we're writing programs that work on Macs and Linux and Windows. Then if you want to be able to skip typing std : in front of all of this stuff, you put the using namespace. And we'll talk more detail about what a namespace actually is. You're always going to have a main function. Int main. Then inside your code, you're going to have several statements in it. Could be 2 statements as this example. It could be 2 million statements, 2,000, whatever. We know what the cout one does. It displays it on the window. If you did not have using namespace here, you would have to type in std : in front of that in order to get it to compile. So what namespace does is say there's a family reunion. There's the Thompson family. Inside the Thompson family, there's Jeff, Bob, Sally, and Susan. If I do this using namespace Thompson, then if I refer to Jeff, it knows that I mean Thompson.Jeff. If I type in Bob, it knows I mean Thompson.Bob. However, if I leave that using namespace off, then it doesn't have a clue. If I don't do that, if using namespace is commented out, then if I type Jeff, it looks for Jeff, it doesn't find it anywhere, it calls it a syntax error. I could get that to work. I could type Thompson.Jeff. Excuse me, Thompson : Jeff. And that would work. It would know who Jeff was at that point. I could type Thompson : Bob. It would know who Bob was at that point. Now, really, this isn't a great example because these aren't variable names, you know, int Jeff is equal to 0, that kind of stuff. But I hope that gives you the idea. If you have a namespace and you don't have a strong, compelling reason to have one yet, then in order to prevent having to prefix all of the items in that namespace with this ... nomenclature, then you tack on that using namespace.
What's a strong, compelling reason to have a namespace?
Say you got real tired of typing Thompson : Okay, that didn't answer your question. That's why you use the using namespace. You do that to divvy up your programs. You could have several thousand programs in one project, or you know, conceivably you could have 3 or 4 even in a simple project. And then if you are, that's actually a very good question. I'm going to make a new project to demonstrate it. Seems like my resolution has changed again. This is in microscopic mode. But I will zoom the text in when I'm entering code. All right. So if I have a program that looks like this, yeah, it's changed again. And I have several functions that are going to manipulate the same data. Can we get this larger? What has it done? All right. And we have a void say hello function that's supposed to say hello to somebody. And we have another function that's supposed to say goodbye. And we want them all to share the same variable. We want one variable that is shared between these functions. You can do that by declaring a variable outside of all of these functions. I'm going to go ahead and add my # and include iostream. And even the using namespace std. So if I want, I could do name is equal to Joe Bob. And then if I want to say goodbye, cout goodbye arrow Joe Bob, or name. endl stands for end of line. I forgot to declare the data type for that. Name contains a string of data, string of characters, so I had to call it a name. And then when we call say hello, not sure what's going on there. I forgot to add the string header. Thank you. This is odd. There is a default string data type that does not do everything we want to do. So there we go. That fixes that. Then I can come down here and I can do another cout that prints hello. And if I want to print hello down here, I could do that. I can do hello, say hello, and I can do say goodbye. And since we've declared this variable outside of any of the functions, it's available both to that function and that function. This code, as written, would not work if I put this variable right here. We could modify it to make it work. The way you would modify it is you would pass it in as a parameter. But as is, we could make this work. We could put the variable declaration above all of the functions, and then it'll work. That's what's known as a global variable. The problem comes in if somebody else writes a program, a CPP file, and they also define that global variable. Then there's global variable collision. And it's either not going to compile, or if you reference a global variable, it may grab the wrong one and pull it in. Now that's not a problem in other programming languages like Java, which are a little bit more structured, where everything has to be in what's known as a class. But in this one, it's not like that. So I could do this, namespace, and whatever the name of this program was. hello. Why did I make it in caps? I don't know. But anyways, then when I want to refer to that global variable, I just preface it with hello. Like that. If I want to access that variable even from another file, I can do it with that nomenclature as long as that I know that it's available. Realistically, I'd probably, I'm not going to go there. But that's the idea behind namespace. It prevents collisions between your naming schemes. Two different files would define, each file would declare their own namespace. Does that help?
Yes.
All right, so are there other ways to do that? Yeah, when you're writing classes, the idea of namespaces kind of starts to fade because a class is a more sophisticated version of a namespace that has all the functions in it as well as the data. So special characters, // we know what that means. That's the beginning of a comment. The # begins a preprocessor directive. We've only seen one of those, I believe. We've seen # include. However, there are others. I could go here and do # def Joe's program. Excuse me. Define Joe's program. Now this is dumb, but I'm going to do it. Down here, I could do if def Joe's program, and don't do this. Then the name is equal to Joe Bob. It's yelling at me. Else string name is equal to Sally. End if. There we go. What this is saying is that since this is defined, that name will be initialized with the value of Joe Bob. If it wasn't defined, if I took this line out, then Joe's program is no longer defined. And then you notice it even grayed that out, but then it highlighted this one with colors. Now this is active. So you can make your code vary based on what is defined. So # define is a preprocessor keyword. If def is a preprocessor command. What does preprocessor mean? What preprocessor means is that when you're going to make a program and you click build, first thing that happens, theoretically, that you know about is the compiler comes. And it takes your .cpp and it turns it into some sort of machine code, some object code. And that's saved as a .obj file. And this differs from language to language. Java doesn't behave quite like this. Then a linker comes along and links all your OBJ files into an executable or an app or whatever. So you have the compiler, you have the linker, but before that you have something called a preprocessor. What the preprocessor does is it looks at your CPP file, and if there's a preprocessor command, it follows that command. The contents of the IO stream file are inserted into this file. As far as the compiler is concerned, it doesn't insert it, we don't see a whole bunch of text suddenly appear in our program. But conceptually, the contents of these two files is inserted into the beginning of this file before it compiles. And so that's why when this line is missing, if I comment that out, then all of a sudden, these things are no longer going to work. Why? Because the IO stream code defines what cout is, and it defines what CIN is. And without that stuff being included up at the top, it no longer knows what those are. So preprocessor means even before compiling, start doing stuff to my program. We're not going to use a lot of preprocessor commands. We'll use # include in every program. We may use this # define and # if def a little bit. And then there's some that we put in header files. Open and close brackets. We see these in different places as well when you're comparing numbers, if x is less than 1. But specifically, those enclose the file names in your # include.
Is there any variation, like if you're, I mean, does the program know when you're using an inequality as opposed to like closing or opening and closing a file name?
It's absolutely based on position.
Okay.
Whatever. So it knows that that's different than that just because it's following an if statement and it's inside parentheses. There's actually two things you can put after # include. If you do # include and you put something in quotes rather than in angle braces, it means it's stored, it's bringing in a header file that's in the same directory as your CPP file. But if it's supposed to search the computer, the search path for that file, if it's supposed to find that in Microsoft's libraries and the C++ libraries, then you put it in angle braces. So when we start writing our own header files, we're going to put quotes there. Now that's wrong. I totally made that look wrong. Although it looks cute, it's kind of an emoticon, huh? But you either use angle braces or quotes. You don't use both. You either use that or you use that. If you use double quotes, it means open a file that's in the same directory. If you define your, won't even go there. Open and closing parentheses. This is a real stupid description for it. What do parentheses do? They group parameters or operations together. What do I mean by that? Here I have a function called say goodbye. I could make it take a string as a parameter so we could tell it who to say goodbye to, like this. I'm going to call the string in. Then when I wanted to say goodbye to somebody, I could go down here in main and I could give somebody's name. We're Lord of the Rings fans today, so we're saying goodbye to Frodo. There we go. This data is being passed inside into the function, into the say goodbye function. This is a parameter. A parameter is a variable that's defined within the parentheses next to the function name. So we are giving some data. This is known as an argument when you're feeding a parameter like that. This argument feeds this parameter right here in now becomes Frodo for the purposes of saying goodbye. That's what parentheses are used for. They're used for defining parameters or for grouping math statements. And what do I mean by that? What if you had to do this? Int x is equal to 3 times 2 plus 4. You've done math with parentheses on your calculator. Why do you do that? You're just forcing this part of the math statement to happen before that one. So what would that equal? What's 2 plus 4 equal to? 6 times 3 is 18. That's opposed to this. If we did x is equal to 3 times 2 plus 4, maybe you remember from junior high or whatever, multiplications happen before additions. They have higher precedence. PIMDAS, please excuse my dear Aunt Sally. Parentheses happen before anything, then multiplication and division, then addition and subtraction. So this expression actually means 3 times 2, which is 6 plus 4, so that's 10. We'll hit a slide on that and talk more about that in depth. But that's what you use parentheses for in an expression, is to force something to happen first. In this case, I know that I wanted to do the addition before I did the multiplication, so I forced it. And whenever you're not sure the order of things are going to be solved in, feel free to use parentheses, even if it's not necessary. If I took this expression here, x is equal to 3 times 2 plus 4, and I wanted to make it a little bit clearer that that happened first, I could put parentheses around it. This already does happen first, but it's even clearer, isn't it? You look at that, you know instantly what's happening first. That's the alternate use for parentheses. more common, well, I won't say more common. You use them when defining functions, parameters of functions, and you use them to control the order of expressions. When I use the term expression, I mean a series of numbers or variable names and operators. These are what are known as operators. Asterisk means multiplication. That's an operator. The plus sign means addition. That's an operator. There's another term besides operator you will hear. So if our operators right now are plus and times, I love using those grade school terms. Then if you do this, A is equal to B times C. The operator is times. The operands are the things that the operator is manipulating. So the operands are B and C. Technically speaking, there's another operator in this expression. There's that one. But let's just stick with the math operators that perform mathematical calculations for now. I can make a more complex expression. A is equal to B times C plus D. We have two operators there. We have the plus operator. What are its operands?
C and D.
Yeah, C and D. And then we have the multiplication operator. It also has two operands. It has B, and it's got another one, which is the result of that other expressions. So whenever you hear me use the word operand, it just means the thing that's on one side or the other of the operator. To me, that sounds like it ought to be a different term. I don't remember hearing the word operator and operand doing, high school, junior high math. Maybe we call them arguments or something, but in programming, the argument is the thing that you feed to fill a parameter. That's an argument. Oh, curly braces define a block of code, a group of statements. Several places you use curly braces. To mark a chunk of code as being attached to a function. Now whenever I want to run say hello, I'm going to break this. Whenever I want to call say hello, it runs all the statements that are between the braces. That's called a code block. You can have code blocks that are functions. You can also have code blocks that are conditionally executed, if statements. If 1 is less than 2, that's real dumb, but if 1 is less than 2, then I want you to print, wow, really? /n means go to the next line, just like endl did up here. You can use them either way. You'll just see me vary between the two. Okay, so this is another code block. This could be 1,000 lines of code, but it's only executed if 1 is less than or equal to 2. Now that's really dumb. Instead, this would probably be a variable, int x. You ask the user what x is. In this case, is it going to run this code? It's not, because x is 3, which is not less than 2. This is what's known as a condition or a conditional expression. It gets evaluated. If it's true, then whatever is inside the braces, that code block, gets executed. If this evaluates to false, which in this case it is, then it's skipped. So that's what braces do. Double quotes are for strings. Single quotes hold a single character. Double quotes enclose a string of characters, which can even be no characters at all. This is correct syntax. If I wanted to, I could come up here and say, this is really confusing up here, but let's enter another name. String last name equals, there. I don't even have any data between those things. But it's still a valid string. I could print that out. It's just not going to print anything. This is what's known as an empty string. It's still a string, it just doesn't have anything between the quotes. Characters are defined with single quotes. My initial is J. You have to put one character there, though. You can't do an empty character. I can't do this. Initial is equal to dot dot. That's not a character. The absence of a character is not a character. I can't put two characters there. That's looking like a Pokemon emoticon or something. Okay, there. It let that happen. Shouldn't have. Realistically speaking, okay, now you got me curious. If I have that, and I try to print out that initial, what's it going to print? Let's find out. All right, I've got some errors. Whenever you define a function, if it has a return type, if it's not defined as void, anything other than the word void has to return a value, and the return type has to match that. I'm going to change that from int to void, because void means, oh, it's okay, you don't need to return anything. And as a matter of fact, you better not return anything. All right, let's build it again. This is typically what you do. You run a program, or you write a program, and then you spend the next 10 minutes debugging all the syntax errors. Okay, I'm getting a warning down here. You can't read it, and I don't know how to blow up the size of that, but it says, warning, truncation from integer to character. I don't know what that means. That doesn't look like an integer to me. But here's another case where I have a function and it's not returning a value. Since it's declared as an int, I could just come down here and do return 0. That means every time that function is called, you can store the return value and find out what it does. Alrighty, we got it? Well, we did, but I forgot to put my pause at the end of it. System pause. You can change the debugger settings, so you don't have to do that. Alrighty. For some reason, when I said my initial was JEFF, it decided that the initial was equal to F. Let's change it and find out if it's always the last letter. What if I made it equal to XYZ? This is just experimentation because I've never done it before. You're only supposed to make it one character. Yeah, Z. It's ignoring the rest of it. I don't know why it's even letting that happen. Double quotes are for strings of characters. Single quotes are for a single character. Double quotes you use if the data type is string. Single quotes you use if the data type is char, character. A string is a series of characters. So the cout object, we've been using it. It's got a technical name. I'm not going to use that word very often. That's the stream insertion operator. What that means is that this program has an input stream, which comes from the keyboard, and it has an output stream, which writes to the screen. And there are other kind of streams. You could open a connection to the internet and pull data off the internet, and that could be a stream. Or you can open a file and read from it, that would be a stream. Or you're going to open a file to save your data, that's another stream. But in this case, for cout, that means console output, which is the window on the screen. And arrow arrow inserts data to go to that screen, to go to the output. Am I going to call it stream insertion operator? Very rarely. I'm just going to say arrow, arrow. Now that gets confusing when I'm typing C out arrow, arrow versus saying C in arrow, arrow. If I say the words, type C out arrow, arrow, quote, hello, end quote. What I want you to do is this: C out, arrow, arrow, hello, end quote, and then remember that there's supposed to be a semicolon. Now if I say type C in, arrow, arrow, name, semicolon, this time I remember to tell you semicolon, you type CIN, arrow, arrow, name, semicolon. How did you know which one to do? Because C out, the arrows always point towards the output. C in, the arrows always point away from the input because you're filling in that variable. You're always taking some data and stuffing it in to the output so the arrows go from the data to the output. Here we're reading in from console input, which is the keyboard, and storing it in the name so the arrows point away from the CIN into the name. I'm not going to, sometimes I'll say less than, and greater than, in which case it's even easier to figure out which. But if I mess up, if I don't say that, then you know. And I guarantee that when I'm up here typing, I'm going to do this. That's an error. Then I'll go, oh man, and I'll have to fix it. You may never do that, but I'm likely to. I just know from past experience. So you use stream insertion to send output to whatever is here, whatever stream is here. Right now we're only using two streams, C out and C in. If you do not have that using namespace, you have to tack that on into the front of it. Many people consider that more professional, not to use using namespace STD, because using namespace STD brings in a whole bunch of variable definitions that you may not want. I appreciate not having to type STD : in front of everything, so in this class I do it. But when you Google up code examples, usually they will have STD : in front of all the C outs and C ins and end lines. You can send more than one piece of data to the screen. You can chain them together like that, or you can put them on separate lines. C out hello there, or C out hello there. So here, if I'm going to print out hello followed by my name, I put that on two different. I put that all on one line like that, but I could have split that up into three separate prints. Void say hello to. I'm using the void keyword because if it's declared as void, it's not going to return a value, and I can skip typing return 0 or something like that. I could do this, say hello, C out hello : name. Do you remember why we have that hello : because we defined a variable up here in the namespace hello. And so this tells it where to find that variable. That variable is not being passed in as a parameter. It's not defined above it. So it's a global variable, and we just have to go figure out where it comes from. And whatever is in front of the : tells us what namespace it is in. Okay, so anyways. These three lines do the exact same thing as this one line does. Which one do you like more? It's up to you. You just have to remember, if you want to print an end of line, you want it to go to the next line, just like hitting enter on a keyboard, you either do that or you do this. That's \n, \, like that.
Is there a difference?
No.
Just whatever you like how it looks.
I'll tell you when I use them. If I'm doing this, C output, my name is Mud. I don't like typing this because I have to close the quotes and then type in an extra 1, 2, 3, 4, 5, 6, 7 characters at the least. I would rather do this. My name is Mud /n. But if I'm printing the contents of a variable out, int x is equal to 3, cout x equals, like that. I'd rather not do that. I could. There's no reason not to, but I just go ahead and do that. Your choice. Totally no reason to choose one over the other. Whichever you think is easier to read and easier to type. This produces one line of output, but if we put a /n here, it would say programming, not M, programming is fun. This is what's known as an escape sequence. When C is processing a string for display, if it finds a backslash, it thinks that the next letter is a special thing that causes something special to happen. It's not just part of the alphabet. And it's true, /n means go to the next line. There are other ones. /t means go do a tab, like the tab key, skip a certain number of spaces. So in my program down here, my increasingly messy program, I'm going to do cout eat. No, we'll do it all in one sequence. Eat /t at /t Joe's /n. When it prints it out, it's going to say eat followed by some spaces, at followed by some spaces, Joe's followed by a character turn. Tabs are a cheap, lazy way of trying to line up your data. There are better ways, but that certainly works for some circumstances. You can give that a stab for lining up your data in columns, and if it doesn't work, then try something else. What do I mean by that? Well, I'm going to put something else under here that also has 3 words. I/T, love /T, Metallica /n. Now when I run that, they should be in the same columns. The problem comes if this piece of data was too large to fit there. Let's figure out how many characters this tab actually is. I bet it's 8. So when I hit tab, it jumped to that spot. So that's 1, 2, 3, 4, 5, 6, 7, 8 characters. So if I have something that's more than 8 characters, cout Pink Floyd /T is /T cool. There we go. It's not going to look as good. For one thing, there's no space there, but that's not the point. Let's. I just couldn't think of a band name that was longer than 8 characters. Soundgarden. Alrighty. Anyways, you see what happened? Pink Floyd was too big to fit in that column, so when it hit tab, it went to the 3rd column. Just like on a. So tabs aren't a perfect way for lining up data, but if the chunks that you're printing out are less than 8 characters long, it's a cheap, easy way of doing it. And there are still other ones. Besides /n and /t, there are others. /n equals new line. /t means tab. If you want to print out a double quote in your string, you use /quote. That looks funny, but what if you wanted to do this? Cout, my favorite word is groovy. And if we expected that to work, it wouldn't. Why? It thinks that that's a string. And then all of a sudden, oops, I'm going to take the /n to make it slightly easier to read and replace that with the endl. But still, you get the idea. To make this work, we would have to do this, \\. Now we've turned this into an escape sequence. Escape meaning that we're escaping the ordinary processing of this text, and when it hits this, the thing that follows the backslash dictates the special behavior. In which case the special behavior is not that the quote ends the string. Instead, it just represents a symbol. Also, you can do the single, the apostrophe the same way. A double quote that doesn't end the string, and slash apostrophe is a single quote. You don't use that one very much because this actually works. Cout I love ice cream. Now the fact that ice cream is in quotes makes me scared, like it's not really ice cream. But that would work. It would print out. Why? Because it doesn't think that that's ending a string. Once you open a quote, it thinks that everything after the double quote is all part of the string until it hits another quote. So it's happy with those apostrophes there. You don't have to preface them with backslashes. You could, though. It would print just fine either way. The endl manipulator. We know what that does. It goes to the next line. I'm doing too much lecturing and not making y'all type in any code. We're not going to have any in class today. Which means I'll actually have to take a roll. Oh no. Okay, so you don't put quotes around endl unless you actually wanted it to print out the letters endl. This is a lowercase l and not a 1. Y'all already know that. /n escape sequence does the same thing as endl, except you put it inside the quote. Programming is /n fun. We'll print out programming is fun. # include. We've talked a lot about that already. It inserts the contents of another file into the program. This is a preprocessor directive, not part of the C language. So, now, there are horrible things you can do with preprocessor commands. You could practically write your own programming language using preprocessor commands. And we're not going to go there because the results are very difficult for somebody else to look at and understand. You don't put a semicolon after the end of include. If I come up here and put semicolons here, it may not hurt, but it's not good syntax. And why? Doesn't every statement have to have a semicolon? Yeah, but these aren't statements. These are preprocessor directives. When the compiler processes it, it opens that file, it inserts the contents of that file right here, and then the file no longer has that line in it at all, just the contents of what it was pointing to. Variables and literals. A variable is a named place in memory. It has a type, and it has a name, and it has a value. Well, this one doesn't have a value yet. Actually, it does. It has a value, but we don't know what that value is. The compiler it's uninitialized, meaning whatever happened to be in those couple of bytes is what winds up in there. Now, if you're compiling in debug mode, then it fills it with a very specific value. But let's prove that. Let's declare an integer and then write it out without having actually given it a value. So I'm going to come down here after all the Pink Floyd Metallica stuff, and I'm going to do int u for uninitialized, like that. And then I'm going to say cout u is, for u equals, followed by u, followed by endl. Let's find out what it is. There were build errors. Oh, it didn't even let me do it. Is my build error there, or is it somewhere else, though? Uninitialized local variable used. It didn't even compile it. There are times when it will let you use uninitialized variables, and the results can be catastrophic. So that is why the compiler is taking a stab at preventing us from doing it. If we wanted that to work, we have to give it an initial value of some kind. We could just say x, u is equal to 0. Now it's an initialized value, and when it ran, it would print out 0. So this thing here has a name. The name of it is u. It has a type. The type is int. And the data, the value, is 0. Some languages, you don't have to specify the type. If you're using Python and you feel like doing name is equal to Joe, then you feel like turning around and saying, no, I've decided that name is equal to 1, 2, 3. And then you decide that name is equal to turtle.newTurtle. Whatever, you know. That's totally okay in a language that is not strongly typed. Strongly typed means that you have to declare the types of the variables and you can't change the data. Now that u is an int, in the same code block, I can't then turn around and say, oh, u is equal to Joe. Why? Because that's not an integer. C++ is a strongly typed language, as is Java. Python and JavaScript are not strictly typed languages. One thing that people often do is define all their variables up at the top of the function. That's totally okay. You can also declare them right before you use them. It's kind of up to you to decide what makes your program easier to read. Here, I have a variable called u. Here I have a variable called initial. I have another one called last name. Another one called x. If I wanted to, I could put all of those declarations in one place. If I thought that this made the program easier to read, I could cut that, Control X, paste it up here. I could cut this, paste it up here. I could take that initial, paste it up here. I could take that u, paste it up here. I think that's all of them. It kind of makes the program look more structured, right? Like, you can look at this, and if these had comments describing what these variables were, you could understand more what the program was going to do. However, a lot of languages don't require you to stick them all the way up at the top. Only a few do anymore. As long as you define them before you use them, as long as X was defined anywhere before the statement, it's all good. Just up to you to decide what makes your code easier to read. And when I'm giving silly examples in my code here, I will define the variable right before the example. Because otherwise you'd have to tab up, or I'd have to tab up for you to see what the declaration was. But if I'm writing code that I want to, give to somebody because I think it's professionally written, I will probably put most of the variables up at the top. And then I would document them. / user last name. / I would describe what X is. / initial. / year. All right, guys, we are about done for today. A literal is a value that is, it's literally written into the program code, man. Okay, here it is. That's a literal. That is a literal. It's not a variable. Once you type hello there inside your code, like this, this is always going to be hello there until you go in with an editor and change it. If I say this, that's a constant. Nothing is going to go sneak in and change in the bytes of the code this value to 216. Once this gets copied into year, the value can change all we want. But these are constants that are entered into the code itself, literally typed into the code, so they're literals. That's the only way I can remember them, the term, or the only reason I can explain why they're called that.
Do you always use an equal sign with literals? Yeah,
because if you just did this, no, you don't. You're correct. Hey, neat. It didn't flag that as an error. What does it do? What do you know? Anyways, that's not doing anything. It's sitting there in the code, but it's not doing anything. Here's an example of using a literal without an equal sign. That's when it's being passed in as a parameter. But behind the scenes, you could think of it as being name equals Frodo, because this is going in and filling that name parameter in that other function. All right, guys. Let's stop here.